I welcome everyone to the second session of Hackfest Day 2 and a very interesting topic of network automation and scaling. So I will revisit the big picture that Mark has shown earlier. It is about that small business that we're talking about here. And we'll see that how this entire system is able to self-adapt through automation. And what we specifically will see today is a wiki service that this business is using and how it can scale on demand. That means scale when the traffic is high. So what we'll be doing here is we'll use the wiki package to instantiate the wiki service, then stress it, and see when there is an extra load that comes to this wiki service. Is it able to scale automatically, and thanks to the scaling feature of OSM that does this scaling of the wiki, and the extra traffic can be handled by the scaled out instances. Okay, so let's start with instantiating this wiki service. So what we have to do, you have to go to the management VM and first copy those scripts which will help you to create the packages and upload the packages and then instantiate the wiki service. So the first thing that you have to do is you have to go to your management VM. I'm already there. You have to use your Hackfest credentials that you have to get into your management VM. The second thing is I have to copy the credentials. Okay, I am not sure whether you already have the these slides. So let me share with you these slides. Okay, so here are the slides. And now I am in okay, so I am in the management VM right now. The first thing that you have to do is you have to go and copy the wiki scripts. You use this command and copy the scripts here. Once you copy the scripts, you will see there are two scripts that are copied. One is the wiki build.sh and wiki launch.sh. The wiki build.sh slide script is for building your wiki network service package, uploading it in OSM, and the launch will actually instantiate that wiki service. Okay, so let's start doing this one by one. So the next thing that we'll do is we'll build this package, but I want to warn you that if you already have an OSM package and you want to use it for a some other work and you want it to be safeguarded, then you should copy it, because this script is going to delete your existing OSM package. So if you already have an OSM package here, what I will recommend you that move it to some other name or rename it to something else so that you don't lose this work. Okay, and then you go and build your package. So what it will do, it will clone the package from Git and build it and upload it in OSM. So it's downloading the package.
Yeah, sorry. Should be going now. There it goes. Sorry.
Yes.
Most people should have done the Git clone already anyway, so.
Okay. Now it should work, yes. So what you see here, it is building the package, uploading the package into OSM and getting it ready. Just before the instantiation, it will have everything ready for you. So just to check this, go to your OSM instance. Okay, to check whether the packages are installed properly or not, you will see this Wiki Network Service Descriptor package and the VNF Descriptor package are uploaded in the package section of OSM. And now you are ready to launch a service. So, but before that, to make it quicker for all of us, what I will do is I will ask you to do a small hack here. And what is that hack? So, so this is the VNF descriptor package. How I went there, let me go back again. And here, go to the VNF package. In the actions, go and do edit and look for this this threshold that we have put in. So we have put a threshold for CPU going high above 80. So it takes time to go above 80. So I will make it 40. So it means that just when the CPU utilization crosses 40%, it will start scaling out, and that will make it quicker to see the scaling happening. Otherwise, we have to wait for a longer time, and that may not be possible within the time of this session. So after you have done that, go and update it. If you don't find it, just let me know. It is on the greater side of it. Change 80 to 40 in the scale out threshold. Once you have done that, go back to your management VM and use the second script, which is your wiki launch.sh. So, okay. So before going to wiki launch.sh, we can also see that packages are all there by running this command. So you can see that your NS package is there, the VNF packages is there, the one that are uploaded with the wiki build script. Now, the next thing is that we'll go and launch the network service. We'll go and launch the network service here. But before that, keep in mind that you have to change the threshold higher, the higher threshold to 40 from 80, which is the default value. Go and launch it here. Okay, so the launch of the network service has started. Okay, so it is instantiated now, and you can go and see this in the instances section here. So what you see here is that the service has started instantiating the wiki service that we have seen in the big picture. It has started instantiating here, and it will take a while to come up. And let's see as it comes up. You can just refresh it here and you can see it's coming up. Okay, so now this service has come up. It's all green. We can see this in OpenStack as well. If I refresh it here. Okay, so what you see here is I have two different VDUs in this VNF. One is for the HA proxy, and another is the actual web service, which is the Apache web server. And the HA proxy has an external IP 174, whereas the Apache has an internal IP. So we'll have to route all our traffic through this external service. So what happens here, if I go back to the slides and show you things happening, so you can see that NS list, you can do an NS list to see your network services are all up. Okay, so this is my network service, it's there, it is ready. And now the next thing is the OpenStack server that we have seen. Okay, so maybe some DNS issue, but we can see it here. It is already there. If you so there is a small bug. So if you don't get an IP address of 192.168.28.2, you will not be able to see the you will not be able to connect the HA proxy to the Apache service. But that doesn't stop us from doing other things. But if you have got address 2, then what you will see is you will see a if you connect to the HA proxy through the external IP, you will be able to see the OSM logo because you are able to finally connect to the Apache server. As we are not able to do so here, so what happens is if I go and connect here, maybe I get a 503 because I'm not able to connect, but that doesn't stop us from doing rest of the things. Okay, so here, what we'll do now as a next thing is we'll see that if this service is getting monitored in the monitoring module in Grafana. So if you go to Grafana, which is your IP, I mean your OSM IP, and 3000 is your port that you have to use. And if you go and connect to this, you will see your the new dashboard that has come up here. So you have a wiki service, and that has started monitoring here. So the memory has come in, and CPU takes some more time to come in. The reason for the metrics coming up bit late is because there is a collection time. The collection time in the Vim, the OpenStack here, and also there is a 30 seconds poll interval for this MON module of OSM in which it comes back and collects the matrices. So cumulatively, so there is a gap between the two, or there is an interval between two different collection cycles, and that is why it takes some time to start collecting, and then we'll start seeing the things. So I hope you have reached up to this point. If not, let wait for all of you to be here, and I'm also waiting for the CPU to come in, which takes some time. Till that time, let's go and visit some of the other interesting things in this session. Okay, I'm jumping few slides and coming to the architecture itself, and why this particular thing is scaled out. What is the scaling architecture that helps me to scale out? What is the overall interaction of this MON module with other modules in OSM to help this automation to happen and so on. So we'll talk about all of this now. Okay, so so I will be specifically talking about the service assurance module, and here we'll be talking about the different components of the service assurance module, which is MON, the monitoring module, which primarily does the collection of all the matrices. Then there is POL, which is handling all the policies, all the action that has to be taken. Then there is PLA, which will not come in this particular session, maybe, but in the next session we'll talk about that. The PLA is about placement. I mean, if the current VM is not sufficient for this particular service, we can move it to some other service. So it decides the placement. And there are two other very interesting things. Grafana you have already seen, where the matrix dashboards are present, and Prometheus, which is actually the time series database, which is keeping all the matrix values so that it can be seen through the Grafana dashboard. There is also an interesting auxiliary service called ELK or the Elastic Stack, which is used for the fault management, which is not part of this session, but it is good to know that we have something very interesting which can be also installed separately. Okay, so then two things that we'll be talking about here is auto scaling and alerts. Auto scaling is whenever there is a threshold of the collected metric that increases beyond a point. If we have a scaling descriptor which sets specific rule, you have seen that already we have set it up to 40. That means that if CPU crosses 40% of CPU utilization, then take some action. And the action here is scale out and instantiate new instances of the wiki service. There is another mechanism that is called alerts. So alerts is, for example, I don't want to take an action myself as OSM, but I want to pass it on to an external system, maybe a more broader fault management system, which can take this notification and take an action at a more end-to-end level. For example, there's an external OSS, which when aware of that there is some problem in the network service, it can take a broader action, not only scaling this particular service, maybe taking some other action outside the purview of this network service also. So this alert helps you to send an message or send a notification to an external fault management system also. So with this, maybe we can see some of the architecture details of MON and POL, which is actually helping you to achieve this scaling and alerting functionalities. So before that, let me have a quick look whether I have got the CPU. Yes, the CPU has also started coming in. So I will try to start the scaling process because it takes some time, so that you can also complete the scaling within the time frame of this session. Okay, so for that, we'll go back to our hands-on session and resume from where we have left. So we have this CPU and the memory that is already there. And now maybe I will go to the HA proxy machine and start stressing this wiki service. For that, what I will do is say I will take the wiki service here. So this is the HA proxy. So I will go to the HA proxy's external IP. I will take this IP and I will log into this HA proxy. And the login and password is Ubuntu and OSM 2021. So Ubuntu. So I'm in that HA proxy machine. How did I go there? I used the public IP of the HA proxy machine, which is 172.21.18.174 for me. I used the login username Ubuntu and the password OSM 2021, and I'm here. Now I will stress this wiki service from here. For that, I will use another command, which is this one. Just copy paste this command, and this will help you to stress your network service. Okay, so for that, okay, one thing that I forgot to tell you is you have to change the IP to your Apache server's IP. So the Apache server's internal IP is .192.168.28.5. I will use this IP here. Okay, so this is my IP and start stressing it. It started stressing it, and after some time we'll keep eye on this CPU utilization graph here, and after a point it will go high, and if it crosses 40%, maybe we'll see that scaling happening and the extra VM spawning up. Okay. So let's see where I am. Okay, and if it stops, maybe after this many message sent, you can again restart it so that the stress doesn't end here, and the CPU doesn't come out, CPU utilization doesn't reduce. So to keep on increasing the CPU utilization, we have to keep on stressing this with this command. So if it stops, then restart it again. Okay, so I think there are a few messages also. Let me see if I can answer a few of them. I get apt socket received no root. Okay, it is something to do with VPN. Okay, instantiation done, very good. Okay, so maybe I will resume my session on the architecture part, and we'll keep an eye on this.
Subhankar,
Yes.
there's someone who's still getting the 503 on the HA proxy.
Yeah.
You had the instructions on how to correct your HA proxy, or does it matter if they're getting that?
Yeah, so so that is a bug in this, that if you don't have an IP address of 192 for this HA proxy, 192.168.28.2, you will keep on getting 503. So even I am getting a 503 here, but that doesn't matter actually. So what that's why what we are doing is we are getting inside this HA proxy machine by logging into this. That's what I have done here. I've gone into this this machine, and I have stressed the load from inside the HA proxy machine. So so that's a bug. So but we can ignore it for the moment. So ideally, what should have happened? You know, like in Sol 6, we should have a provision to forcibly give this IP address, which we could not fix it. That is why, at least I could not fix it myself. So that is why I am not able to give this IP address 192.168.28.2. It is getting 4 right now. So even I am getting 503. So though the HA proxy has started, but I'm getting 503 because it is not connecting to the backend services. Okay, so Now coming back to this. Okay, so back to this, what I was just talking about here. Just keep a watch on this stress. It should not end, because if it ends, maybe your CPU utilization will come down quickly. So
Yeah,
the CPU utilization.
quick note on that. The default OpenStack metric interval is 5 minutes. So in any production environment of OpenStack, you will typically not perform a scaling action on an event that occurs for less than 5 minutes. So for this Hackfest, we have shortened that interval to 2 minutes to make it more responsive. So you are going to need to keep that load running for at least 2 minutes. Otherwise, you will not receive a scale operation.
Thanks, Mark, for this. Yeah. Um, so this is not a ultra real-time system, ultra real-time monitoring that happens. So this is not meant for that. It is mostly for, as Mark said, right? I mean, if things are for a longer time, and I see there is an issue, then it has to be taken. So it's more in the production system. What is going to happen is things that happens on a longer span of time. It just does happen in a minute or so. So that has to be observed, and an action has to be taken more on a long-term basis rather than sporadically. Somebody is saying Grafana is empty in my case. Is it for everybody? Because I have things. Okay, somebody is saying that stress testing is not having impact, but as Mark said, that it takes some time to reflect, because collection interval is at least 2 minutes. For if you see here, my collection has started and stress is happening now, and it has crossed 60% already. So if it is crosses 60%, then the scale out would have happened. And if I refresh OpenStack in a minute or so, it should increase the number of VNFs. Okay. Okay, so you see there is video 1 of the Apache service. That means the scale out has happened. And interestingly, it also starts monitoring the scale out instance. So after some time, we'll see that it starts monitoring this. Okay, so this load has stopped, and I will not restart it back because I have already seen the scale out has happened, and I will now let this load go down and let the scale in start happening. That means if it now crosses the lower threshold, which is 20%, the extra videos that are created will be removed and it will come back to the normal situation. Okay. So the question, there seems to be some messages in here. You just, if your load has stopped, you can, and you have not seen that scale out happen, you can keep on stressing it and scaling it up. For example, for my case, I did for some time and it reached 60% already. So if it is not happening in your case, keep on stressing your Apache web server with this command. If it stops, start it again, and after the collection cycle, is hit, the collection will happen, and you will see that it will shoot up to this percentage. Okay. I think tall guy is saying the CPU is not come. CPU, interesting. CPU takes more time to show in the CPU panel. That's what tall guy is asking. That he's not able to see CPU. Hope tall guy can see CPU now. It takes some time. Memory comes faster, and CPU takes some more time. So there are a couple of collection cycles that happens. So in OpenStack there is a time series telemetry system called Gnocchi. So that has a collection cycle of default 5 minutes that Mark just said. We have reduced it to 2 minutes now, just for this session to be more responsive. And then we also have a 30-second poll interval of in OSM-MON. So if you already have the code of OSM-MON, you will see here that it has a collection interval of 30 seconds. So it will come back in every 30 seconds, and then it will come and try to collect the matrices. Okay. So with that, let me go back to my presentation and talk about some of the internal architectures of OSM and specifically the service assurance model. So what you have seen is that the scaling has happened, the extra the video has come up. The Grafana credentials, I think somebody is asking Grafana credential. The Grafana credential is same as your OSM credential, so your Hackfest credential. So it will be OSM underscore Hackfest underscore your user ID number. And same is the password as well. Okay. Now, so there are two modules that came into picture when we did that scaling. One is the MON module, and there is another called POL module. The MON is the monitoring module, and here what happened is there is a collection service, MON collector, which is collecting the matrices. So here it is not the VCA, rather it is the Gnocchi client from which it directly connects. So it connects to the Gnocchi client of OpenStack and gets the CPU and the memory matrices and puts it in the Prometheus database. And then the alarms that are there in that VNF descriptor that comes through Kafka from NBI through Kafka to the MON server, and they get registered in the common DB, the MongoDB. The MON evaluator is again a set of processes, which is a process pool, which collects this alarm information and also sees what is the current matrix value. For example, it is collecting the current CPU information. Says CPU information is tells me that CPU utilization is 60% now, and the alarm says that if it is 40%, raise an alarm. Then it will evaluate that is 60 greater than 40. Yes, then raise the alarm to Kafka. And then it goes to LCM and to RO, and it scales out. If it is a scaling operation, or it will go to an external system within webhook if it is a alert that will be generated. There is another model called POL. While the alarm management happens in MON, the actions or the policies are kept in POL. That means, do I need to scale out? Then what is how much I have to scale out? What I have to scale out, and so on. So those actions are kept in POL. Do I have to scale out or scale in? How many instances to be scaled out? So all this information is kept in POL. And if it is a alert, then the webhook information that has to be alerted has to be kept in there. Okay, so this is a more comprehensive alarm architecture. So as I said, that the MON evaluator, when it evaluates that there is a there is alarm that is generated, it gives it to Paul, and Paul then gives it to LCM for scaling out. If it is a alert, that goes to a Webo. Okay, so we have also seen this scaling descriptor. We have increased or reduced this 80 to 40 already. So there is a scaling descriptor, that is the policy that tells you when to scale out. You see that there are operations like greater than and less than. The greater than tells me that, okay, if the CPU utilization is higher than 80%, then I have to scale out to an scale out instance. If it is less than 20, then I have to scale in maybe, and which is the VNF that I have to use for scale, or which is the video I have to use for for scaling. That means which video will be scaled out or scaled in, and all those things, and which is the parameter that I have to use, and so on. Okay, so that's all about the current architecture. So let's revisit and see what happened to my OSM wiki instance. Okay, it's still showing 47. So it has started coming down, but it will take some more time. So once it starts coming down, it will start scaling in. But interestingly, what you see here is the two additional videos that were instantiated because of the scale out operation has also is being monitored now. In fact, there are 3 or 4, I think. Let's see how many of them are here. So you can scale out maximum of 10. That is what the descriptor tells me. So it has 0. So 0 was already there. 1, 2, 3, 4. So the 4 additional instances are scaled out, and 3 of them are already monitored now. And you see CPU also, the first one is getting monitored. So this is an interesting thing, that it is not only about the initial video that was scaled out. All the subsequent videos that came up because of this scale out will also be monitored here, through this Grafana dashboard. Okay. So it seems there are a few questions also. Let me see what are the questions here. Password for Grafana, username as password is same as your Hackfest username as password. I hope you got that. Don't use admin. Please don't use admin. I will talk about a new feature here that helps you to use your own tenant. You will get overwhelmed if you get into admin. One is that if you delete something there, that will stop that entire monitoring. And also the second thing is that you will see dashboard of other participant, that, and then you will get confused. So don't use admin. Please don't use this. Okay, use your own Hackfest credentials here. If you have a problem, just let me know. Okay. So okay, one thing that you see here is the extra traffic has now subsided. So it has fallen to less than 1% now. So the scale in operation should also start in. Okay, the vertical scaling is not. This is an interesting thing. Do we really want to support vertical scaling? So, but at least for now, we are not supporting a vertical scaling. So what is an horizontal scaling and vertical scaling for everybody to know? The horizontal scaling is what you have seen now. That means if there is an extra traffic, then additional video of the same VNFs will be created, or the additional VMs will be created to handle this extra traffic. Vertical scaling means use the same VM, but increase its compute resources. For example, increase its memory, CPU, storage, and so on. So rather than instantiating a new VM, the same VM is provided to more resource. So many a times it doesn't work very effectively, because if a service is already running and you suddenly increase the disk, maybe it is not able to pick up the disk, or if you are increasing the CPU, is not able to pick up the CPU. So it is not always easy for a network service or a service that is running inside the VM to pick up vertically. Though I mean, it is not globally applicable. It is all case by case. But what we have seen is horizontal scaling works perfectly for all the different kinds of VNF that the vendors are bringing in. That is why horizontal is something we support, and vertical is something is at least not implicitly supported by OSM. Okay, coming back to this. Now it has the extra traffic has reduced, so we should start seeing the scale in triggered. Let's see, it's happening now. Okay, the fourth video has gone, then the 3 will go, 2 will go, 1 will go, and only 1 will remain. That is the normal condition. So if you keep on watching here, you'll see that gradually the extra VNFs are gone. So this is the elasticity that it brings in to handle the extra traffic. For example, say during the office, because it's a business, right? So say from say 8 a.m. to 5 p.m. in the daytime, I see a lot of traffic. So I increase the wiki traffic handling capacity by scaling it out, and then when the office hours are over and people go home, maybe they don't use the wiki service at that point of time, and it can scale in. So it can then saves we can save the extra compute resources that would have been otherwise lying idle. Now it can be given to somebody who needs it. So depending on the traffic, depending on what is the usage pattern, I can decide how much resources will be given to a particular service, which is the small business here. Okay, so we have seen both scale out and scale in happening here. Now, what is new in release 9 in the service assurance model? The one that you are already seeing it here, that is the RBAC feature extended to Grafana. Okay, so what is RBAC? So RBAC is something that you're already using a role-based access control. That means every user of OSM is given a controlled access to the OSM's resource based on his role, whether he's an admin, whether it's a project admin, system admin, or a normal user. He's given access, and this access is that helps him to get hold of the specific resources. For example, if he is a project admin, he can get access to his project. If he's system admin, he can get access to projects across OSM, and so on. So so what happens generally is whenever a user logs in through the northbound interface, maybe through an NGUI or through a command line, he is asked for his credentials. So you have all used your credentials to log in, and then we are using a common DB to authenticate you. That means your username and passwords are all there. And then when you're authenticated, you get an access to OSM. Now, there are other ways to do that. For example, say, rather than using an internal database, I want to use an external database, and then I have a keystone in between. So the keystone helps me to connect to an external database like MySQL database that we use. So rather than connecting to an internal database, you can use an external database to connect to your to hold your username and password, and use it for authenticating the users. And the third is that say for this kind of case where it's a small business, I already have an LDAP. So you're already seeing the LDAP as an example here. You have an LDAP to keep your user details, and that gets connected to Keystone, and you're able to connect to API. So what happened before release? So what we did, so we extended this RBAC feature which was there in OSM to Grafana now. So now all of you can see that you have dashboards. You don't have access to others' dashboard. For example, if I go to home and go to manage, I only see my own user and or own dashboards, my project dashboard and my wiki service dashboard. So I don't see others dashboard. But if you have been into the previous Hackfest, then you would have seen that this was not the case. So though you are logging to OSM using your own, own specific users, but in Grafana it's only admin dashboard, and that was overwhelming. So I will show you an example here, but please don't try this out. Okay, this is just to show you. So if I log in as admin, you need not you please don't try this. I'm just showing you. Okay, somebody has changed the admin password already, so I cannot show it to you anyway. Okay, I don't know who has changed it. So I wanted to show you that if I log into as admin, I will see all the users dashboards together. So that is very confusing for me. But I somehow am not able to log in through admin because somebody has already changed the password. I don't know who has done that, but so it is not also advisable to log in through admin. Okay, so but when I log in with my user, I only see my own dashboard, and that is good for me, that I am not barging into other space. Nobody else can barge into my space and tamper the work that I am doing. I am also able to easily locate my dashboards properly and so on. So this is what you are seeing here. Okay. And so before release 9, it was like only through admin you have to log into Grafana, and everybody's dashboard is in one space. Now you have in release 9, what has happened is the same credentials are passed to Grafana. That means that the same username is also available in Grafana, so that like you can use your own credentials to see your dashboards in Grafana actually. So how it is done? So when we designed this feature, so there is no direct one-to-one mapping. So in Grafana, in OSM RBAC, there is a concept of user, and users are connected to projects. Projects are connected. Projects have role, and then there are NFV, the network service, and the VNF, which have dashboards. Now, the users are directly mapped to the users. The projects are mapped to the team. The roles are mapped to the team permission, and the dashboards. The network services have that, or the VNF have the dashboard actually. So if you see here. I don't know if I can see from here or not. Okay, I think if I'm not admin, I cannot see it. Okay, I cannot see all the teams because I'm not admin, and somebody has changed the password to admin also. Okay, so what I wanted to show you here is that how the teams and the users were connected, but as I'm not able to connect as admin, somebody has changed that password. So that is why we don't see the dashboard there. Okay, fine. So this is all I had for this session. So what we have, so in summary, what we have seen here is there is a small business that has a wiki service which has the details about the business, maybe what they're doing, and all the projects that they have. And we instantiated that service, and then when we have an increase in network traffic, we did that by stressing that Apache web server. We see that the scale out has happened. and we have seen that the extra VMs were created for the Apache web server to handle this extra traffic. That we saw that in Grafana we are able to monitor these matrices not only of the first VM of Apache web server, but also the additional VMs that were created because of the scale out operation. And then when the traffic was taken out, then the scale in operation also was triggered, and all the extra VMs were gradually removed. So I will see what is the condition now to show you that if all of them are removed or not. Okay, so all of them are removed, so it is now in the normal condition. So that is pretty much that I have. Let me see if there are any question. Wow, scaling is also successful. Excellent. Okay, so I think I am done with this session. Anybody has any more question, you can just unmute yourself and ask it now. Okay, there's a question from Alam. With this performance monitoring, can OSM also do the VNF fault management? Meaning, if an existing VNF is not reachable, can OSM redeploy the VNF? Okay, so this is not part of the scaling. There is another feature that will come up maybe in release 11 or maybe beyond that, is auto healing. So what it will do, and we have already, if you have been attending the tech calls, we have already presented the first version of that design to TSC. There we have been discussing about if, say, a VM or a VNF becomes unresponsive, and for that, how you can see the VNF becomes unresponsive by looking into the one of the metrics that is already collected. That is, you can see it here also. Just a minute, I can show you. Okay, so you see here that the VM state is up. So VM status is up. So we keep on monitoring the VM status. But this is only for showing in the dashboard. We are not using it to reboot the VM or reinitiate the VM. In the auto healing feature, what will happen is it will be used to maybe trigger some action. What are we discussing there is, should that action be taken by OSM, or should that action be also defined by the VNF vendor? So what you have seen in scaling, the scale in or the scale out operation is not decided by OSM itself. It is that VNF descriptor of that VNF that tells me what action that I have to do. I just read that information model as OSM, understand what is the criteria on which I have to do the scaling, and do I need to scale out or scale in, which operation that I have to do. So it's a VNF vendor who is creating this information model inside the VNF, and he is asking me to take some action as OSM. Okay, so it is not that OSM can take an action without the VNF vendor telling them what to do, because say there is one VNF which has multiple different videos, and if they have to be rebooted, they will be rebooted in particular order. For example, say you have seen here this wiki service which has HA proxy and an Apache web server. If both becomes unresponsive, the entire VNF becomes unresponsive, which one should I reboot first, HA proxy or Apache web server? If I am a VNF vendor, I will say that, okay, you first reboot the Apache web server, see that it has come up, and then only you go and reboot the HA proxy so that it can connect to this Apache web server. Otherwise, just rebooting the HA proxy may not work, because your Apache web server in the backend are not there. So, so it is the VNF vendor who has to tell us what reboot order that has to happen. So this is what we are discussing in our tech sessions. What should be the information model? What should be the way to for the VNF vendor to define what will be the action that has to be taken for healing to happen. So in summary, answer your question, what you have just mentioned is not part of scaling, rather it's part of healing, which is getting defined. What we are now into is defining the information model so that the VNF vendor can decide what healing action can happen. Hope that answers your question. Okay, I don't see any more question, and I am almost in time. There are only 3 minutes left. So if anybody has any question, he can unmute himself or herself and tell your question, or we can end this session and I will hand it back to Mark.
So one thing that we just discovered over on the Hackfest Slack channel is each participant has an OpenStack quota of 10 VMs. So depending upon, if you have the virtual desktop or that basic VM still kicking around or any of the additional things, you are only going to be able to scale your wiki to a certain number of instances. I believe that the network service descriptor itself allows us to scale up to 11. But of course, we have a quota maximum of 10 set in OpenStack, which means that you're never going to be able to scale to the maximum in the descriptor. That was a miscommunication between Subhankar and myself. I probably should have let him know that when he was preparing this. So my apologies. If anyone notices that after a certain number of scale operations, it's not scaling anymore, it's probably because you've reached your quota, and it's not going to OpenStack will inform OSM that you've reached your quota, and OSM will report back to you, failed to scale more units. Now, if you let it scale back in, and then you add load again, it will go ahead and scale back out. But in the interim, when you're at your maximum quota, you won't be able to scale any further beyond that. And here Subhankar is showing where max scale level is 10. And considering that there is 1 instance for the load balancer, that is already 11 instances. So we should probably change the max scale level to 4 or something like that, just in case. But we'll coordinate better for future sessions. So thank you for bearing with us on that one.
Absolutely. So this we should have figured it out earlier. So this is 10, and what Mark is saying is, I think we have a overall quota of 10. So we are not able to go beyond that. Let me see.
Correct.
Somehow it's not connecting. Oh, somehow it's not connecting now. So anyway, we go to the overview, we'll see that you have a quota of 10. So yeah, so you have a quota of 10 here. So and you have other VNFs already. So might be it is hitting the max limit. Okay, so that ends this session, and I think I'm on time. So thank you very much, everyone, for your patience. And if you have further questions, put it on Slack. I'm there to respond. Thank you.
Absolutely. Well, thank you.